Matt Webber with you. This is Sport by Experts, delivered to your eyes and your ears by Bond University. The crack of leather on willow is as synonymous with the Australian summer as the drone of cicadas, zinc cream on your beak, and beach sand that burns on your feet. And with the first test of the Ashes only a few weeks away, not even now, 10 days away, things are certainly heating up. But cricket is an outdoors game, and that means it relies on good weather, particularly here in Queensland, when the rumble and roar of seasonal storms often brings an early close to a day's play, which brings me to my guest on the podcast today and how limited overs cricket matches are decided when that summer rain just won't go away. Dr. Stephen Stern is a Stanford-educated mathematician who, for quite a while now, has been a professor of data science here at Bond University. He's the sports lover who put the S into DLS, the famed Duckworth-Lewis Stern system, the mathematical method by which weather-shortened matches have been decided for near enough to 30 years now, I think. My guest today on Sport by Experts, Dr. Stephen Stern. Hello.
Hello, thanks for having me.
I'm a total cricket nerd, so I can't tell you. I'm almost trembling with excitement at the prospect of nerding out.
Yeah, well, I am used to that because you're not the only one, so don't worry.
I understand cricket reasonably well, and its fans are something else. Now, your accent will betray you for those who are unfamiliar. California to cricket is quite the leap.
You'd think that, but it's not as big a one as you might believe, given my history, because Stanford University, where I got my degrees, has a very strong connection with Australia. A lot of Australian students go to Stanford, and there are a number of professors at Stanford who come from Australia. So one of my best mates during my period there was an Australian, and he was the one who actually got me to be interviewed for my very first job in Australia. So it's not actually as surprising as it seems that I would be in Australia. Maybe it's a little more surprising that I would be a cricket fan.
Yes.
But my friend Michael was a big cricket fan.
So you were well aware before.
So I knew about cricket. I also have family in England, so you know a great uncle and so forth. So I was aware of it as a sport. I guess I'd have to be honest and say I wasn't aware of the details of it. But I knew enough about it that I was able to frustrate most of my new Australian friends who see it as a badge of honor to try and make baseball happy Americans feel foolish when they talk about silly short leg and which when they found out they couldn't do that, they got frustrated. And that was what they said, well, in that case, why don't you go and figure out about this new mathematical thing that even we don't know what the heck it is.
Well, we'll get to that, but it was going to be Chicago, wasn't it? Chicago
so I was
Bond.
hired, at the time that I was talking about, my friend Michael told me about the job, I had my supervisor who was like, you can't leave U.S., we can't lose you to Australia. And so they were running around trying to get other job interviews. And the only one they could organize on short notice was at the University of Chicago, which is a wonderful school. Yeah. But unfortunately for the University of Chicago, they could only organize the interview on the 10th of January. So it was middle of freezing winter, right? And they don't call it the Windy City for nothing. And also, because it was last minute, when I went, I arrived at like 10 p.m. at night. And the University of Chicago, at least then, I mean, this is a long time ago now, was in the midst of a really not very nice neighborhood in Chicago. And so it took me 3 cabbies to get one who would agree to take me at that time of night to the hotel that I was staying at next to the university. And so, I got my offer from the Australian National University, and within a day I got an offer at the University of Chicago, and I had to tell myself, well, it's either nice, wonderful, sunny Australia, or it's the middle of horrifying winter. I mean, there was snow on the ground. It was a pretty easy choice.
Not such a tough choice.
Although I have to say, I mean, I did end up going to, the first place I spent then in Australia was Canberra, which is not exactly sunny, warm Queensland. So there was a little bit of an issue there.
Nice in its own way. Nice in its own way. Now, I mentioned the Duckworth-Lewis Stern system, but it was the Duckworth-Lewis method ahead of that. Now, you've kind of politely nudged your way into the nomenclature here. But this is a really lovely story of academic collaboration, really, isn't it? Tell us how this evolved, because Duckworth-Lewis was around for quite a while before you came
So
along.
Duckworth-Lewis originated, or his first application was on the 1st of January 1997.
Perhaps tell us what it is, because I'm making assumptions here. I'm a cricket trainer. People know what it is, but in your words.
That's actually kind of part of the story, right? So, as you said in your opening, the idea is that cricket is relatively unique amongst team sports in that most other team sports, offense and defense are dynamically played, right? So if you're playing a soccer match, right, one team has the ball for a bit and then the other team takes it away, and same with AFL, the same with rugby. But cricket, right, one team is on offense for a whole long period of time, and then they stop, and that's it, they're done, and then the other team goes on offense and tries to score more runs. And so if there is a weather interruption or any other kind of interruption, Duckworth and Lewis used to keep a list of all the different things that caused matches to have to be shortened.
You'd be good in a trivia competition, I suspect.
Fun.
Methods of delaying a cricket game. Yes.
But it's but because so the idea is that those things don't affect both teams equally, and because of that, there needs to be a way to rationalize how to readjust that. You know, if one team loses 20 overs and the other team loses 30, well, obviously you can't just say, well, you got to score more runs than they do because you have less time to do it in. All right. And indeed, initially, one of the very initial approaches to the problem was just, well, let's just prorate by the number of overs. If you had 50 to get 100 runs and now you've only got 20, well, you got to get 2/5 of the runs. But that obviously, you know, if anyone who's ever played cricket will realize that can't be right, because 10 overs at the beginning of a match is totally different than 10 overs at the end of the match, and 10 overs when you're 9 down versus 10 overs when you're 1 down. Right, so the idea was to come up with a way of fairly adjudicating, and I should probably stop there and say we try and stay away from the word fair because everyone has emotional, right?
Don't worry, I have some questions about that too.
We have, so the word I like to use is equivalent. We like to create an equivalent scenario for the team batting second so that it matches, in a cricket sense, something similar to what the team batting first got. And as you say, that was, so I still refer to both the DL method and the DLS system because there is an important structure there. The DL method was essentially the realization that Frank and Tony had of how best to make that equivalence. And at its core, it's basically what I said before. It's, well, if you've only got 20 overs instead of 50, you've got 40%. But that's not a true 40%. It depends on when those overs are and how many wickets. So what they were able to determine is that what you should do is look at how many overs are left and how many wickets are still available to you. And that's the factors which readjust. And so it starts at a base 40% if you've got 20, but then it goes up or down depending on if you've got lots of wickets or whether the overs are toward the end of the innings or toward the beginning of the innings. So so they figured out the method, which basically said, here's the core principle. Right? It's based on what they call median runs to come. You pick any particular point in a match, and from that point on, a team, you can estimate using observed data, what proportion of their runs would they score in that remaining period with that many. Right? So you have 10 overs to go and 4 wickets in hand. You might look at the data and score, well, in that period, you'd score 22% of your runs. But if you only had 2 wickets in hand, you'd probably only score 12% of your runs, and so on and so forth.
With Professors Duckworth and Lewis, was it simple? Was it scratchings on a beer coaster?
Yeah.
I mean, what they
have the very first formula that they wrote down, Frank refers to as the Waikiki Formula, because he scribbled it on a piece of paper while he was on the beach in Hawaii at Waikiki on vacation. And so that was the idea.
He just got thinking and...
Yeah, it's a fundamental data analytic principle, and I talk about this in my classes a lot, and when I talk about Duckworth-Lewis and other aspects of sports analytics, is that one of the crucial aspects is to find the right picture to understand the nature of the data you're trying to analyze. And most people up until that point had thought over by over by over and go, okay, well, this over, you might score 6, and this order might score 4. But they realized that no, it was the aggregate amount from wherever you were forward that was the best way to think of that picture. And from there, they devised Tony Lewis, his specialty was operations research. So he created what they call an economic returns frontier or a profit frontier, which essentially said, look, you have 2 scoring resources at your disposal. You've got the overs that you can play, but you've got the wickets in hand, and you trade them off in the most optimized way you can to make as many runs as you can. And that was, and they demonstrated that formula could be done using this runs forward.
And so it was for a little while.
Yeah.
But then Stephen Stern arrived.
Yeah.
What happened?
Well, as the game evolved, so as I said, 1997 was the first use, and that was what they called well, it wasn't called this at the time because it was the only version, but we now refer to it as the standard edition. Because at the time, right, in 1997, 50 over cricket scores were still mostly scored in test match mindset, right? Batsmen were very, very risk averse, and they wouldn't, hit out unless they, right, didn't want to lose their wickets. And so most of the scores were nowhere near the scores we see today, right? A good score in 1997 would have been in the low 200s, right? And if you got 250, you almost certainly would win the game. So given that there was a relatively narrow focus of what scores were, the original Duckworth-Lewis could get away with a one-size-fits-all approach. But as the game evolved, right, and there was a period there in the early 2000s where some of the legendary names of the game, right, Ponting and Bevan and Tendulkar and Jayasuriya and all of those, they suddenly realized that, well, wait, we've only got 50 overs to bat. We don't need to finish 3 down, right? If we're 9 down and we've scored twice as many runs, that's much better. And so it said probably I think if you had to pick a single person who sort of embodies that, it would have to be Sanath Jayasuriya, because he was the one who started saying, look, I'm an opening bat, and I know that usually opening bats are very stolid and they try and take the shine off, but I'm only here for a short period of time. And so he was the first one who really started hitting out early.
Famous Sri Lankan.
Yeah. And then he gave rise probably to the other obvious person in that guise, which is Virender Sehwag, right? And so they realized, as batsmen evolved, they realized that the scores they could make were much higher. And it became clear to Duckworth and Lewis, and I wasn't quite on the scene at that point, that one size fits all wasn't going to do it, right? And so they created what now is referred to as the professional edition. And the standard edition was still something used at lower levels of the game in club cricket or domestic cricket.
It's like Trivial Pursuit or Monopoly.
Sense, right?
Isn't
it's a little. But the and the idea of the professional edition was that, right, as the overall scoring rates got higher and higher, the percentages of which how many runs you would score during which period of the game changed a bit. They kind of flattened out. They became more like just the old just 20 overs is 40% of the match. But even at that point, they kind of knew that what they had done wasn't quite going to be able to be sustained forever. And that was kind of when I started getting involved in the situation. But the trouble was,
were you on your own beer coaster somewhere doing?
Well, as I said, I when it became clear to my Australian friends that I wasn't going to fall for drop bears, and that I understood enough about cricket that I could explain LBW.
Yeah.
They then said, well, there's this DL thing that we don't understand, and you're a mathematician, so you should figure it out. And so I read up about it. I found the paper that Duckworth and Lewis wrote, the academic paper, and as I say now all the time, as every good mathematician worth his salt does when he reads some other mathematician's work, he goes, "Oh, that's interesting, but I can do that better." Right?
Politely.
Yeah, politely.
Yeah.
Well, and so I started working on reverse engineering what they had, based, because they to this day the detailed workings of the method are not public. The generic structure is public. but the specific constants that go into the exact construction, the ICC has copyright on them and the IP, and they don't want them to be made public, which I can respect. They're very risk averse themselves when it comes to stuff like that, particularly with things we might talk about later, like gambling. Right? Anyway, so Frank and Tony kind of knew that, look, the game is evolving, and this new thing we've created is kind of a stopgap measure. But they had two problems. One was that they're of an older generation, and their math skills were up to a point, but neither of them were actually mathematicians. As I said, Tony Lewis was an operations researcher, so he's more of an economist. And Frank was actually a metallurgist, believe it or not. He worked, so he was entirely retired when he first started doing Duckworth-Lewis. He worked as a mechanical engineer at a nuclear power plant in Britain.
Gee.
So yeah, fascinating the lives that you carry out. But they kind of knew that they weren't really up to the details of making the thing actually work. But even if they were, they also had the added problem that the game was still only evolving. So even though they knew eventually there would be lots of scores that were 300 and 350, there weren't that many at the time. And so, right, to actually get those specific parameters that we need, you need data. You need observations to say, well, what proportion did they actually score during this period and that period? And so there just wasn't a lot of it, right? So by the time I came on into the scene, things had moved more to closer because so I basically joined the party, if you will, at the same time that 2020 cricket was beginning.
I see.
And so that was if Jayasuriya and Sehwag started the revolution, 2020 cricket was the thing which solidified what you could do with a limited overs game, not having to worry about keeping all 10 of your wickets in hand, right?
I see.
And then the power plays came and all that sort of stuff. So by about 2005, it was clear that there was very shortly going to be a huge database available of these high-scoring matches, and we just needed to wait a little bit and use them to create a new, fuller mathematical adjustment, and that's why I say that's what became DLS, the system. So I used their fundamental principles, the DL methodology with runs to come and percentages, and said, but by the way, you have to calculate those percentages differently when the matches get to be 350, 400, and so on.
They welcomed you with open arms.
Well, that story is quite interesting. They did, and I'm still amazed by it. I mean, Frank Duckworth's generosity of spirit in that regard, because most academics would never have done that, right? And but what happened was I wrote a paper about my idea that I can do this better, and
in the most polite possible way.
In the most polite possible way, and as I said, and then I said to myself, it would just be courteous to send it off before I sent it off to the journals to be published. I would send it to Duckworth and Lewis, not really expecting much more than just a thanks for that, good luck, or whatever, because that's kind of what academics tend to do, right? But, and I'll never forget this for as long as I live, the email I got back the very next day from Frank Duckworth was, thank you very much, Stephen. My wife Jeannie and I are just about to go on a trip, we're just about to go on a trip to the Grand Canyon in the U.S., and I've been looking for something to read on the plane. So he read my article on the plane, and we had several back and forths. They obviously didn't agree that my method should replace theirs, but they did see the benefits of some of the stuff and I won't go into the technical details because that was really, right? But then the next thing that, in some ways, that was the start, but there was a couple very serendipitous further events. One was that at that point in time, Frank was also trying to work on coming up with a ranking system for the teams, because they had this big issue. The ICC was developing all these new, the World Cups and the Champions Trophy, and
you needed to seed teams,
and they needed to seed the tournament, and they needed to decide who was in it and who wasn't, and also they were trying to grow the game. So initially, of course, there were just 8 test playing sides. In fact, initially there was only 6 of them, right? But then Zimbabwe and Sri Lanka came along. But then by that time, Ireland was pushing for test status, and so the game was growing. And then in the one-day area, although there were heaps, the Netherlands was coming along.
Nepal,
and,
Afghanistan.
yeah, exactly. Namibia was a big team. Canada, for a while, was a very big team. So, so they needed to come up with a better ranking system. So Frank was working on that, and he wrote me and he said, I noticed when you wrote your paper that you've obviously done a lot of compiling of a major data set, right, which we didn't have the time and energy to do. Would you mind sharing that with me? And I think he probably, again, just like I did, thought that he would get a polite, well, no, thank you very much, right? I'd spent a lot of time. But so because he was so generous, I just sent it back to him in the very next day.
Wow.
And that solidified this ongoing partnership. And what it then led to, believe it or not, so that was probably 2005. And that was also the time that when the ICC was just switching over to being fully computerized. And they were moving from using DOS-based machines, which is what there was a program that Duckworth-Lewis wrote their original methods on that ran only in MS-DOS.
Gosh, okay.
Right?
Yeah.
And they were, but the ICC was saying, look, we have all these new things that only run Windows, right? They were moved to, I think it was Microsoft Vista, the new operating system, and it would only run Windows-based programs. And so they wrote to me and said, the ICC has been trying to take our MS-DOS program and turn it into a Windows program, but the only people who they have on staff who are, quote, IT people are essentially web programmers who create, and so they just couldn't figure it out. And so I said, and so they were asking, can you help us? And I said, absolutely, I can run. So within, 3 or 4 days, I wrote them a prototype of a program which ran their system, but using Java, which is a Windows-based language. Now, that
well, you're in the club now.
Well, yeah. So a couple of things. First of all, that original thing I wrote was never going to be. I mean, it was very small, and so they kept writing me back, going, "Oh, could we add this bit to it?" And at the moment, the program is about 20,000 lines of code. Almost all of which are just bells and whistles. They make the par score tables, and they make little announcements of, by the way, if you're going to lose overs, you have to lose overs evenly, and all these little. So I built all of that for them, and eventually got that to be used by the ICC as their fundamental program. Right? So that was, and I said, in about 2005 or so.
Are you revered in ICC circles as the keeper of a flame? Because
I think
Messrs. Lewis and Duckworth no longer with us. Of course.
And sadly.
I
don't. There is some interesting, and I don't. The one thing I refuse to do in things like this is get into politics, because there are obviously politics, and in particular, I think one of the things that saved me a great deal is that I wasn't really an Australian, or at least I didn't sound like it, right? Because, there were Indians who thought they had a better system. They didn't.
You've stolen my question. I wanted to ask you about this.
And they were very heavily pushing for their system to be used because they were Indian, right? Had nothing to do with the math, right? And if I had been Australian, following up from a British pair, I think the Indians would have been able to say, that's not fair. But because I was American, they really didn't have a leg to stand on that front.
Instant independence.
But given that, I think these days, most of the people who work for the ICC think of me as an old, comfy, blanket that lies around. And I said, I am constantly answering questions that they get, irate fans saying, why did this happen and why did that happen?
I'm curious about this. In the same way that you contacted Frank and Tony, are you contacted by other mathematicians?
All the time. All the time.
Amazing.
And I am still looking. So unfortunately, most of the people who have contacted me have had ideas, but they have a fundamental flaw, which I'm happy to chat about. But
Please
it's a
do.
Relatively technical one, so maybe in a little bit. But the issue was that that the ICC needed somebody who could comfortably explain this in layman's terms, and partly because a lot of the people who were running then the competition committee, Clive Lloyd, and after him Saurav Ganguly, and they just didn't know how to explain it. Right? So I got the opportunity, and I think because of that, I slowly built up that level of trust with them, so that I think these days I'm probably looked at as a sort of
Does the system have flaws? Does the system have flaws, do you think?
Does the DLS system have flaws? Every system that's mathematically based has flaws, right? But it depends. I guess you have to be more clear about what you mean by flaws. Flaws can come in two ways. Flaws can come because there's a mathematical inconsistency in the model. And that's the problem with all the things that people have been saying to me. When you look at them, right, the thing that caused the problem in the first place, which led to DL needing to exist, was that the rule they had put in place at the time was mathematically inconsistent because it was created by cricketers, not by mathematicians. So it's not surprising that they didn't, so basically the rule that was in place at the time worked beautifully as long as the interruption happened in the lunch break. But if it didn't, the whole thing fell apart. And that's what happened in the famous 1992 match, right? The rain came toward the very end of the second innings, and suddenly...
Who's playing? Put me in the frame.
So it was England and South Africa, right? South Africa was chasing England's score of 245, I think it was. And they were about 20 runs short with 2 overs to go. Or 2 over. So it was 22 runs off 13 balls. Now, these days, that would be, right, a snap. You would say, absolutely, that's an easy win. But in 1992, when you're batting like test matches, it was no foregone conclusion that you would be able to score 11 runs and over, right? So the match was very evenly poised. And then rain came and washed away 2 out of the 2.1 overs. But the way that the system had worked, because it was only designed to work at things happening at the lunch break, it said the adjustment was to subtract 1 run and to go now from 22 off of 13 balls to 21 off 1 ball.
Patently ridiculous.
Yeah, patently ridiculous, right? And so that so that led to that catastrophe led to the ICC having to do something, and that in and of itself is an interesting statement on the ICC, because there are other things about cricket that I think are that need to be fixed. But the ICC doesn't like to move until there's a catastrophe that shows that what they're doing doesn't work at all. So
what would you change?
Net run rate.
Net run rate. Okay.
Yeah, net run rate is a terrible idea, right? But
why? Why?
Well, I think the simplest way to explain it is the same reason that the original ideas for target resetting don't work. It doesn't account for wickets, right? So you can have the same net run rate if you're 1 down or 9 down, and because of that, what that leads to is that net run rate, when you compile it, is differentially influenced by different matches. Some matches influence it very heavily, and if you want a secondary criterion, you want it to be based evenly on all the matches, right? If you have soccer's goal differential, well, that's just total goals that you scored versus total goals that you let in. Even across, you could have, it doesn't matter which match they came in, right? And net run rate just doesn't respect that at all.
There you go. You heard it here. Perhaps not first, but we'll claim it as an exclusive.
Yeah. So, but anyway, so the idea was then that, so something had to be done, because that method, which was called the most productive overs method that was used in 92, had a mathematical flaw. Frank and Tony that fixed that. The DLS system does not have a mathematical flaw. In other words, it's internally mathematically consistent. But, right, because of the way it's been built and has to be built on existing data, it doesn't work perfectly if you have to apply it to a type of match that rarely ever happens. And this has become an issue because, right, about 3 years ago now, maybe a little bit more, the ICC decided to change their criteria for what constituted an international level match, right? And I had promised when I got the custodianship that I would annually reevaluate based on all international matches. And at the time, that was, the 2020, it was only, to be an international level match, you had to be a test team playing it. So there was only, maybe a few hundred a year. And I just, right, meticulously downloaded them, right, to my wife's chagrin. Every Saturday morning, I would sit and download cricket matches for a few hours.
It's not the worst habit, don't worry.
Yeah, there are other.
There's going to be one. Yeah.
Well, I said I'm not divorced, so. But what happened? But they decided, for the sake of growing the game, that they would make any T20 level match between what was effectively a national team an international level match. So suddenly, in the space of a year, there was a tenfold increase in the number of matches. But also, there were matches like Bulgaria versus Croatia, and the Isle of Man versus Jersey.
Do you watch a little European cricket league from time to time?
No.
It's pretty good.
So I think my son has a good friend who his parents are German, and he is now over in Germany playing the German 2020 league.
It's good fun.
And smashing it apparently because, you're, but yeah, so, but the trouble is that, first of all, some of those matches are played on synthetic pitches. It's right, and others. I mean, the teams are just wildly mismatched. So, for example, there was a match in which the team batting first scored 290 in their 20 overs, and they proceeded to bowl out their opponent, who I believe was the Isle of Man. That's why it comes to the tip of my tongue.
The selection pool
right.
issue.
They bowled out the Isle of Man for 7.
Okay.
Right. So there were 8 ducks. Right, and I said, not only was it they bowled out for 7, right, 4 of them were extras.
So DLS won't necessarily factor in those perimeter dwellers.
Right. So if there had been rain during that, now I don't, in the end it wouldn't have made much difference because there was never any hope that they were going to chase down 290, right?
Yeah.
But so you can reach those extremes. Indeed, when I first took over the DLS and made it so. 2014 was when I first took over, but I made the first update based on a data analysis in 2016, and I made the claim that it would work for any matches which were between 100 and 500.
Okay.
And I thought to myself, that's pretty safe. There's never going to be a, right? But not 2 years later, right? The England women's team, oddly enough, scored 498 in a 50-over match. So I thought, maybe I need to go and guarantee a little further out. Right?
It keeps expanding like the universe, like
well,
galaxies.
And that is, and so you said, so often one of the things I get often when people write to criticize the method is they say, look, it gives a totally weird target in this situation, and you look at the situation, and it's, well, the team batting first scored 1,000. Okay. Right? I'm willing to accept that maybe we don't know what's going to happen out there. However, my response generally is, you don't know what's going to happen out there either. So you claiming that your idea that the target should have been 850 instead of 825 is equally ridiculous.
For now, it fits snugly.
Right. So those are the flaws that DLS has. It's just, it is, by its nature and by the fact that this is the way data analytics works, it really can only work on data that it sees and maybe a slight extrapolation. But when you get out past that, nobody really knows. Right? But it's not a fundamental flaw, which is what the problem with all these other things was. There's mathematical inconsistencies to them.
Why numbers for you? Well, what's the fascination?
Well,
Where did it come from?
So my mother is a math teacher, and my father is a research physician. So science and technology was always something that I was fascinated by. I think actually, though, the best explanation is that the other thing that so my 2 major loves in life are sports and puzzles. I get up and every morning I do the New York Times crossword puzzle, and I like the Rubik's Cube, and so numbers are just a natural extension to all of that for me. In fact, one of the reasons I think I'm as good at what I do as I am is that I don't see numbers in the same way that I see numbers as patterns, numbers as these games to interconnect with, and that level of ability to abstract really helps you make consistent and, as I said, internally connected models based on that. So it's not about the numbers; it's about the patterns that they create.
Half your luck. Because I don't see numbers
Yeah,
in anything.
most
like
people
that
don't.
kind
Most
of
people don't.
clarity.
And I said part of the other half of my life, which is my teaching, I try desperately to get my quantitative students to see things different. Right? I like to go and there's certain phrases that all of my students use throughout the years, and so I like to go and keep tabs. And probably the most common of them get because I teach actuarial students and I teach data analytics students, and so they come to me and say, I thought I was good at this, and I just can't figure out your. And I said, look, A, you are good at this. It just gets harder, but B, you have to start thinking differently about it. Right? It's not memorizing all the times tables. It's looking at the patterns that the timetables creates and understanding how that helps you extend the times tables and understand the meaning of the times tables. So I think that is, and look, you're right. I mean, not everybody can get it that way. Not everybody can get it that way. But not everybody can argue sufficiently logically to be a lawyer either, right? So everyone has their strengths and their weaknesses, and that just happens to be mine.
It's an enviable one, though. Data analytics now, in the current climate, we are almost being overwhelmed, swamped by artificial intelligence.
Unfortunately.
And well, unless you hold shares, I guess. Where does data analytics fit into that spectrum?
So, I mean, my wife, who likes to buy me T-shirts of all kinds with slogans on them, my favorite one, which she's trying to get me, is a one with a picture of a Star Wars stormtrooper writing with a chalk on a board, like so he's in detention, and the phrase he's writing over and over is, "Those were the droids we were looking for." Right? So I love that kind of thing. And one of the things that so one of the recent shirts she got me was, "Without data, it's just an opinion." And that's, I think, where we stand with all this. In other words, right? I mean, there are unfortunately prominent people in the world who have decided that opinions are enough, and that we should base our whole life just on someone's opinion, provided that person has enough power. But that isn't the way we need to do things, right? So data analytics is foundational to how we need to view the world, and especially as the world gets more and more complex and more based on detailed scientific discoveries. When Leonardo da Vinci and Isaac Newton were around, you could know everything there was to know about math because there wasn't. But as they developed more stuff, and then Einstein came along and Oppenheimer, and suddenly you just can't know everything, right? So you have to have ways of relying on other people you trust who are doing systematic things which are based on data. And that's the positive of data analytics.
I sort of see it, though, as data is feeding the front end of this machine too.
So the idea is that data analytics is a more sophisticated version of what I said about myself, which is looking for patterns in quantitative information. That's all it is. But and then, well, I guess maybe I should add to that. It's looking for those patterns, and then somebody coming along and interpreting, well, what do those patterns actually mean, right? And for example, the patterns you see in certain numbers do not mean that Tylenol causes autism, right? They mean other things, right? So, but someone who knows a little bit about it has to interpret those patterns, right? However, we've reached a point where the patterns that we're looking for now, because we've found all the simple ones, are so complex that they're very difficult to interpret. And that's where these, things which people refer to as artificial intelligence are trying to find patterns that the human brain just isn't capable of really, intuiting itself. So we're giving away some of our agency to these algorithms, which is a bad idea. Right? As I said, when I give a talk about artificial intelligence, and my closing line is that artificial intelligence is neither. In other words, it's neither artificial, because it's just computers, nor is it intelligent in any way, shape, or form. But you're right. I mean, the problem then is that rather than try and spend as much time as we can figuring out how these things work and why they do what they do, we've spent time monetizing them before they're really ready to be monetized, right? the whole problem with ChatGPT and Copilot and all of those things is that they're out there now in the world and people are using them and they're just not ready yet. They shouldn't have been out there for another 3, 4, 5 years while the people who were building them started going, well, what's actually going on here?
What's the ethics of it, for starters?
There's all, but at its core, right, and I think the term they've now used for it is called alignment. And that is that the thing that those programs, those algorithms are designed to do is not the thing they're being used for, right? And that's why you get these things where, right, it sounds like the algorithm is telling someone to commit suicide, or it sounds like the algorithm is telling someone to leave his wife and go away. But that's just because the algorithm is designed to say words that sound like things that a human might say, right? And it's been trained on Hollywood movies as well as, right, data science papers, and so that's why you wind up in that. And look, there are many technical reasons why I believe it does what it does and why it should be regulated in appropriate ways. But fundamentally, it's that we haven't spent enough time trying to say, why does it do this? And how can we realign it so that it doesn't, right? And that's probably 10 years worth of work.
How would you regulate?
Yeah, well,
where would you begin?
Well, I unfortunately, where you would begin, and this is always a difficult thing for people who have spent their lives doing something, is you need to start again. The large language models, which are the core of things like ChatGPT, are wonderful things. They are never, we've gone as far as we can go with them. They're never going to get any better. They'll just get bigger and bigger and bigger as we try and feed them more and more data on which to try and learn. But right, they're fundamentally not designed to do what people want to do with them. Right? When you do a predictive analytic calculation, so you say, I want to know how much more likely is it that you're going to get lung cancer if you smoke a pack a day. The techniques that are designed to do that look for the patterns which go, what is the relationship between how much you smoke and how often you get lung cancer? So there's a perfect alignment there. The technique is looking for the answer to the question you are using it for, right? But a large language model, their optimization is simply around, does it sound human? But we are asking it questions like, tell me what to do with my life, right? Or should I, go and get ice cream tomorrow or what? And because it sounds human, we anthropomorphize it to the point that we think it's making logical connections, but it absolutely is not.
Can we dwell quickly, because I'm conscious of time, but
I'll stay as long as you want, mate.
the predictive analytical part of data analytics, if you like. And it's a question that came up in the office the other day when we were watching the horse racing. And I was sitting there and I was rubbing my chin and I thought I was oh so clever thinking of this. But I wonder if we're starting to hear the death rattles of gambling industries or share markets because AI in combination with revolutions in data analytic technology, et cetera, et cetera.
It's an interesting thought. Unfortunately, the answer is no. I mean,
I thought I was onto something.
Yeah, well, and there's a reason. So first of all, you need to make, as is common in these scenarios, you come up with an interesting, as you say, water cooler discussion, and it's fun.
Yeah.
Right? But if you then want to be serious about it, you need to start being more specific about the terms that you're using.
I was very serious at the time.
Well, and look, it's not that it's a bad question to ask. It's just that the answer, right? And really, there are two fundamentally different types of gambling, right? There's the gambling that you do in a casino, which we have known the outcomes for and all of the theory for since the mid 1800s, right? I teach the stuff in my introductory probability class. There is nothing about those games that we don't understand.
Right.
Right? Now, there are people who play them who don't understand the mathematics, but that doesn't mean that somebody doesn't understand the mathematics, right? And indeed, if you are clever enough about it, you can put the odds, because of those things we know, you can put the odds in your favor, right? There's a famous...
Flip the script, yeah.
Well, there's a famous movie, 21. I don't know if you...
Yes,
about
yes.
MIT students who would But they had to be very, right, in order to do this, you have to have a team of people and you have to look for special situations. And even then, they only can do it with blackjack because blackjack is the only game in the casino that actually uses just the fair probabilities for cards, right? For example, if you play roulette, right? All of the roulette bets are based on a theory of probability, which is based on the reds and the black numbers. But every roulette wheel has 2 green numbers, right? And so all of the real chances of outcomes are different than the paybacks you get, right? So all the odds are in the favor of the casino, right?
So sports bet and co are safe for now.
Well, so but that said, sports betting though is of this. So there's a second type of gambling which has a human component, right? So you can make a living as a professional gambler, right? Because they know all, or probably not necessarily all, but most of the mathematics behind there. But the way they win and lose has really very little to do with that. They are people readers, right? They're psychologists. They try and see tells in your behavior, right? Which help them, as I said, change the odds in your favor. So it's not that they...
So we're talking about poker now, for instance.
Poker, but also, right, sports betting. If you feel like the bookmaker doesn't know what I know about, there's, oh no, the grass was a little longer, or this horse is really good when it's rainy, and they're not, right? But those are human aspects. They have nothing to do with the data analytics that go into this, right? So what you're talking about there is simply the difference between a scenario where you know the odds perfectly, even if you or someone can calculate them perfectly, versus a situation where you don't necessarily, right? I mean, cards, there's only one way that cards work. But horses, right? I mean, a horse can get distracted running down the back straight, or there might be interference, or or the jockey will whip them in a pattern that is either better or worse, right?
Endless variables.
Right.
Yeah.
And so you can get maybe better and better and better using predictive analytics at getting the odds of a situation right, and that might give you a slightly advantage, right, over the bookmakers, although these days they're pretty darn good at figuring those things out, right? So yeah, I don't think we'll ever, there is a concept in predictive data analytics called the irreducible error, right? And when you fit a data analytics model, there are 2 components to the way in which it makes mistakes. One is it just didn't have enough actual data to fine-tune the pieces of its model to perfection. That's what you might be thinking about when you're saying, well, we can get better and better and better at that. And we absolutely can. The way we do it is we get more and more and more data. Right? But every basic model in data analytics is based on the idea that an outcome is equal to some signal that drives it and some noise that interferes with the signal. And that noise is fundamental, right? It has a certain degree of size. Now, certain things, the noise might be small, right? You hear things in the world of engineering, particularly electrical engineering, of the signal-to-noise ratio, right? And that's a very important thing. If the signal-to-noise ratio is very high, then what we call the irreducible error is a very small component. But if it's the other way around, if there's a fundamentally noisy situation that it says, look, even if I knew everything there was to know about this horse, I still can't make a prediction beyond the noise that's in the system of horse racing, right? And so if you could now, unfortunately, as with most things, knowing the exact size of the irreducible error is hard. But if you did, suppose you could say the irreducible error in this case is 20%. Then no correct model, predictive analytic model that you would fit could ever have more than 80% accuracy.
Right. Okay.
Right? So there are fundamental caps on that. And they have to do, right? The size of that noise component is often heavily dependent on what extent is a human being involved, right? Because if you try and do sports betting, you've got no idea if someone's going to catch their cleat on a hole in the ground and get injured, and suddenly the dynamic of the match is complete, right? There was a baseball player for the Los Angeles Dodgers. They ended up winning the series anyway, but the poor man had his young daughter pass away, and so he couldn't play. You can't put that into your model and say, yes, I predict that there's going to be a death in the family of so-and-so, and that's going to, you just can't do that.
What about the odds of a ball wedging under the wall?
Exactly. So those are, now, at least, in things like that, sometimes there's enough information that you can kind of go, well, the trajectory was. And,
Yes.
Right? But yeah, there's a fundamental level, particularly where human beings are involved, that, right, even if you knew everything about, right, and this is what we explain. Suppose you had two scenarios, two games, and they were identical games in every possible way that you could measure. They still wouldn't have the same result. You have to play the games to see who's going to win and who's going to lose, right? So we've already reached a point where we, A, understand that, and B, in most sporting situations or betting situations, we have a pretty good idea of how to calculate the odds, right? Some of them were not as good as others, right? And I said, and there's also some interesting, there's a wonderful book by Nate Silver, who is a mathematician and data analyst. He's the guy who created the website 538.com, which is where he predicted all of the U.S. congressional races, and right. And his book is all about, when can we make good predictions and when can we make bad predictions, and what, right? And one of the greatest examples in that book, which I love, is earthquakes. Because we now understand earthquakes to the extent that we can predict with incredible accuracy the number of earthquakes and their general sizes that are going to happen in a 2-year window. Right? We can say, in this 2-year window, there's going to be 38 earthquakes on average, and there's going to be 4 of them that are bigger than 7, and 2 of them that are less than 4 on the Richter scale. Though they don't use the Richter scale anymore to measure earthquakes, but that's a separate issue, right? So we know a lot about the overall pattern. But if you then say, okay, can we predict the next earthquake? The answer is not even close. Right? Not even close. So things are, the scale on which we work with things also has something to do with how good or bad we are. And again, it's not because we don't have enough information or enough mathematical skill. It's because there are things that are fundamentally random. Right? At its core, human existence is fundamentally random. Right? There are aspects that cannot be deterministically focused. And sometimes that component is huge, and we can't predict earthquakes, individual earthquakes. Other times it's relatively small, and we can go, no, I can predict the totality of earthquakes really, really well.
I think about this, and I'll bring it back to cricket, but the entire industry that is devoted to predicting the outcome of an Ashes series, we do love to speculate.
Yeah, and I think you said, I think what you can say about the progression of this is, so I have another colleague who used to make his living by betting on tennis matches. And what he noticed was that the people who ran the betting sites back then, which he did this in the late 80s and early 90s, had a really bad model for estimating how often a person who was 5-2 up or 5-1 up would win the set, right? They predicted that person would win almost 90% of the time. And my friend did an analysis which said, no, it's closer to 75.
Right.
So it's a big difference.
There's a margin.
Right?
Yeah.
And so he went in, and every time there was a 5-2 set, he would bet on the person with 2 to win. Now, of course, he didn't always, right? But he had so much better odds than the odds that were being used to make the payoffs that he made massive amounts of money. In fact, he had to he got so good at this and made so much money that he had to intentionally lose every once in a while, so that the people wouldn't kick him off the site, right? Because it's, you're winning too much. Now,
it's not a bad problem to have.
No, that's right. So, but what happens in these circumstances? My friend got hired by a betting company to fix the problem, right? So, and as I said, so we've reached the point where for casino games we already know everything, and for other games we're reaching that point where we're pushing up against that irreducible error. Right? But that irreducible error being there means that there's always going to be a place for if you want to try and gamble. Now, you shouldn't, right? Because all of those games are rigged against you, right? You know, and it's amazing to me how they you know, these things, and sometimes I wonder and worry that they do these things and people just don't pay attention, right? Ages ago, they forced the tobacco companies to put pictures of people with throat cancer and stuff, horrifying looking pictures, onto the cigarettes in the hopes that this would cause people to look at it and go, oh God, I'm not smoking. Didn't work at all, right? People just put brown bags over the cigarettes and didn't look at any of it. And the same is true for you know, for gambling. Is people think they know better than these, and so. But now the gambling companies are saying, you know, you win some, you lose more, which sounds so trite that I don't think anyone would actually, you know. I mean, I have known you know, friends of friends who have ruined their lives gambling, right? And it's because they, and it's interesting, it's a problem that is sort of bimodal, right? The people who bet, particularly on sports, are either people who just do it because they think they know something and they really don't, or they're the people who really do know stuff, but they get so caught up that they forget that, wait a minute, I actually know enough to know that this is the wrong thing to do, right? The odds are not in my favor, but suddenly they think, no, but I can do it. I can just, right? You know, and I think this is the, I said, there are some very famous examples of, you know, the ideas in gambling that people get caught up with. You know, there used to be in the 1800s a very famous fad called the martingale scheme, which was if you were playing a sequence of games that were 50-50, if you just doubled or nothing every time until you won, you would always be a winner.
Yeah.
And this, you can prove mathematically that's true. The only problem is that in order to actually carry it out, you have to always be able to double or nothing, which means you need to have an infinite bankroll, right? Which never happens, right? Which is why the casinos don't have to worry, right? Even if they didn't put 2 greens in the roulette wheel, even if the game was totally fair, you can show that if you follow a sequence of fair games, that the person who's going to win in the sense of taking all their opponent's money, if you keep playing until one person is bankrupt, the probability is proportional to the ratio of their bankrolls. So if you're going up against a casino and you have $500 in your pocket and they have 500 million, the chance that you're going to get all 500 million of their dollars before they get your 500 is ridiculously tiny. Even though each of the individual games is 50-50, right? So the concept of fairness is an interesting, right, and elusive one.
My head is exploding, so we're going to have to leave it there, Stephen.
Well, let me just, I wrote a paper for The Conversation a little while ago, which I called The Perils of Illiteracy, right? Because in my opinion, right, there are 3 fundamental educational shortcomings. Most people think of 2, right? Illiteracy, which is not understanding words, and innumeracy, not understanding numbers and math. But I believe there's a 3rd, and I called it illiteracy, which is not understanding probability correctly, right? And the interesting thing about that is that most people who are innumerate kind of know that they're innumerate, and so they shy away from numbers, right?
Yes.
And other people who are illiterate know they're illiterate, and they don't shy away from having to read publicly or give, right? But people who are illiterate think they understand probability, right? They think they know what it is, and they will, right, do things that you look and go, that is insane. Why? Right? Indeed. And the reason I call it illiteracy is that playing the lottery is an insane activity. No one should buy lottery tickets, right? Fundamentally, you never win the lottery.
But it's the gift of a chance.
So here's the thing. Even if you win the lottery, you don't really win the lottery, because where do you think all that money comes from? Right? It doesn't come from the lottery company going, oh, let's give away $5 million this week. No, it comes from all the poor sods who didn't win that week and all the weeks before, right? So it's not a good idea. It still boggles my mind that in this day and age, given everything we know about STEM and all, right, that there are still state-sponsored lotteries. It's insane, in my opinion. I can't understand why people would choose to buy lottery tickets.
Lovely to chat to you, Stephen.
Thank you very much for having me.